Hello, this is Ms. DB, and today we are going to finish our lesson on using algebra to solve linear systems and focus on solving systems of equations by elimination. So when we use elimination, we eliminate or get rid of one of the variables by either adding or subtracting the equations. You may have heard this called linear combination or even the addition method before. Sometimes the equations are set up to do this right away. Sometimes you have to multiply one or even both of the equations by some number to create two equations that can be added or subtracted in order to eliminate a variable term. Here is the steps that we're going to use in order to do elimination. We are going to first add or subtract the equations to eliminate one variable. Now, in the first few problems, that will be ready to go. It'll be set up. How do I know if it's set up, if it's ready? You'll have one variable term that's a positive, one that's a negative, and they'll have the same coefficient, the same number. So in this one, we have plus 2y and minus 2y. So they're ready to go. They're set up for elimination. If they are not yet set up, then you may have to multiply one or more of the equations first. And we'll look at some examples where you have to do that. But these are already set up. And then you go ahead and you solve for the other variable. So when we add these together, the plus 2y minus 2y cancel, and we're left with 3x plus 5x is 8x, 7 plus 1 is 8. And this real quickly, divide by 8, we would find that x is equal to 1. So that's step 2, to go ahead and solve. Step 3 is now that it's the same for substitution now. Now that you know one of the variables, you plug it back into either one of the original equations, doesn't matter which one, and then you solve for the other variable. So this example, they picked to solve back or plug back into 3x plus 2y equals 7. That was the top equation. And wherever they see an x, they're going to put a 1. So 3 times 1 plus 2y equals 7. Well, that's 3 plus 2y equals 7. And then they subtracted 3 from both sides to get 2y equals 4. And then divide by 2 to get y equals 2. And then the last thing you need to do is write that as an ordered pair with the x, comma, y values, and then check your answer 1, 2 back into both equations and make sure it works. All right, let's look at this example. First of all, you want to see, is it set up? We have a 3x and a 4x. You can't add those and cancel. But we also have a plus 2y and a minus 2y. So it looks like the y terms, if we add these two equations together, are going to cancel, eliminate. So we go ahead and we add those two equations together. When we do that, we get 7x, because these cancel, equals 4 plus negative 18 is negative 14. Watch your signs on these. It's quite easy to... You're going to get not good answers, incorrect answers, if you had added these incorrectly. And we divide by 7, and we get x equals negative 2. Now remember, we also have to find y. So now you go back and you look at your equations and you pick which one do I want to plug negative 2 back in for. Probably the top one is a little bit easier. 3x plus 2y equals 4. So then I already found that x was negative 2, so I replace the x with negative 2, which would give me negative 6 plus 2y equals 4. And then add 6 to both sides, and we would get 2y equals 10. Divide by 2, so y equals 5. So that's the second part. And then we write that as an ordered pair, and then we would check that. And we can check it by plugging this back in for x in each one and this in for y, or you could graph it and see if they cross at that point, or you could do a table of values. All right, here's our steps again. So we're going to go through and do some of our examples from your homework, from your worksheet. And it starts at 6 because remember your first part of your worksheet was on substitution. So let's see, is number 6 already set up for elimination? We've got 2x and minus 2x. We also have plus y and minus 3y. That's, the y's don't work, but the x's will. So I can just go ahead and add these together. And when I do that, I would have 1y minus 3y. These cancel. 1y minus 3y is minus 2y. 1 plus 5 is 6. So we solve this for our first variable, and then you take that value and you plug it back into one of your original equations. And I'm using the top one. You can use either one. If there's one that's easier with less negatives and smaller numbers, then you might as well make life easy for yourself and do that. Now, I didn't really need parentheses around this negative 3. I could have wrote this as 2x minus 3 equals 1, which will make the rest of this a little easier. So 2x equals 4, divide by 2, and I would get x equals 2. Don't forget to write your answer as an ordered pair, and then you should check your work on scratch paper and make sure that it works in both equations. Number 7 is set up because we have plus 4y and minus 4y. And number 8 is set up because we have plus y and minus y. So each of these, when you add them together, you'll get a nice simple equation to finish solving for one of the variables. In both of those, you're going to get x equals something. All right, now sometimes you have to do a little bit more work. So let's look at some of those cases. We have 2x and 3x, can't cancel that, and 4y and 3y. Neither of these variables are going to cancel if we add it together. If we just add it together now, we'd get 5x plus 7y equals negative 13. That doesn't help us out at all. We'd still have an x and a y, and we wouldn't be able to solve anything. So what we need to do is we need to say, all right, is there something that I could multiply the top equation by to get 3's? Not really. Is there something I can multiply the bottom equation by? Could I multiply 3x by something to get 2x? No. Can I multiply 3y by something to get 4y? No. You don't want to do decimals and stuff. So what I can do is say, well, I could change both of these into 6x and minus 6x. So I could multiply everything on the top. I could find a common multiple, the least common multiple of 2 and 3. So the least common multiple of 2 and 3 is 6, because 2 times 3 equals 6. I want one of them to be a positive 6x and the other one to be a negative 6x. It doesn't matter which one is which, but that way they'll cancel if I have a 6x and a negative 6x. So I decided to multiply the top equation by 3 and the bottom by negative 2. Now when we multiply the top equation by 3, we have to multiply both sides of the equal sign by 3. And when we multiply the bottom by negative 2, which again will give us that negative 6, you have to multiply everything by negative 2. So 3 times 2x is 6x, distributive property here. 3 times 4y is 12y. 3 on the other side, 3 times negative 10 is negative 30. For the second equation, negative 2 times 3x is negative 6x. Negative 2 times 3y is negative 6y. And on the other side of the equal sign, a negative 2 times negative 3 is positive 6. Now I can add these together, and it's set up for elimination because I have a 6x and a negative 6x. So that cancels, and I add 12y plus negative 6y, which is 6y, and negative 30 plus 6 is negative 24. Divide by 6. Divide by 6, and you get negative 4 for y. Now take one of your original equations before you multiplied in order to find the other variable. Once you multiplied, you could have made a mistake, plus they're more complicated. So I'm using the second equation of 3x plus 3y equals negative 3, except I'm going to replace the y variable with negative 4. So 3x minus 12, because 3 times negative 4. Add 12 to both sides, and you get 3x equals 9. Divide by 3, and x is equal to 3. Write this as an ordered pair. X is 3, that goes first, and then comma, negative 4. And then check your answers and make sure that it's a true statement for each of those equations at that point. And that is the solution to that system. Another example is right here. I'm going to go through this one rather quickly so that we can get to some problems from your worksheet. In this one, I decided to eliminate the x term again. This is very similar to the one I just did. And again, the least common multiple of 3 and 2 was 6. And we got a y value of -5 and an x value of 3. And we can check it. And here's your problems from your worksheet. Let's look at number 9. On number 9, it's not yet set up. We have a 2x and a 5x. We can't add those to eliminate the variable. And a 6y and a -3y. Can't add those. However, in this one, I could multiply just the bottom equation by something in order to eliminate one of the terms of the top, or with the top. So if I multiply -3 times 2, I would get -6y, and the top equation was 6y. So I'd have -6y and a +6y. So I'm going to rewrite the first equation exactly as it was. I didn't change that one. You don't always have to multiply both equations by something. The second one now becomes 10x minus 6y equals 88 times 2 is a big number. 16, 2 times 8 is 16, 176. Now the 6y and the -6y will eliminate, and I'm just going to be left with the x term. So I'll have 2x plus 10x is 12x equals -8 plus 176. I need to subtract 8 from this. So that's 168. And then we would divide both of those by 12. I wonder if it's, whoops, I wrote 13 because I was thinking the answer might be 13. I know 12 times 12 is 144. I wonder if 12 times 13 is 168. No, it can't be. 12 times 14? 4, 0, 2, 1. It is. So it's 14. So x is equal to 14. Now don't forget that once you find x, you still have to find your other variable, because we're looking for the point where these two lines would cross. So it wouldn't make sense just to stop at x. So then you take your value of x, 14, and plug it back into one of your original equations. I'll use the first one, 2x plus 6y equals -8. So I'd have 28 plus 6y equals -8. Ugh, I don't know why my pen is making these lines. Minus 28. It's when I touch another line. So I get 6y equals -36. So y is equal to -6. So my solution would be the point 14, -6, although I should plug those back in and double check using a calculator that I would get a true statement on both sides. All right, let's just look at how to set up the last two and not solve them. So in number 10, there's nothing I can multiply 5 by to get 8, and there's nothing I can multiply 8 by to get 5. There's nothing I can multiply 3 by to get 5, or vice versa. So I need to think about what is the least common multiple of either the x terms, 5 and 8, or the y terms. Now I'm going to go with the y terms because this one already has a minus and a plus. That's a good start. And because their least common multiple is 15, which is smaller than 40, so I'll be working with smaller numbers. So that means that I need to multiply everything on the top equation by 5, because I want to get -15 for the y term, and everything on the bottom by 3, because I want to get +15 for the y term. So 3 times 5y will be +15. So go ahead and multiply through your distributive property. Don't forget to multiply the right side as well. And your resulting equations will be 25x minus 15y equals something. And then the second one will be 24x plus 15y equals something. So the minus 15y and the plus 15y will cancel, and you'll be left with a something x equals something. In 11, right now we have 1/2 x plus 1y equals 4. We could just multiply everything on the top by 2, and then the top would be 2y for the y term, and the bottom is negative 2y. So if I just multiply everything on the top by 2, that will be set up, because 2 times 1/2, that's 1. I'd have 1x plus 2y equals 8, and then rewrite the bottom equation exactly as it was. I didn't change that. And then you can go ahead and add them together and solve for your x term. It's not always the y terms that are easier to cancel. It just was in these couple examples. All right, as you learned in lesson 3.1, sometimes you have parallel lines and they will never cross, so there will be no solution. Sometimes you have lines that they are, when you graph them, they're the exact same line, and then you'd have infinitely many solutions. So that can happen when you solve these with algebra as well. So let's look at this example. We go ahead, in order to do these problems, you go ahead and you start solving. So you can either pick to use elimination or substitution. It's up to you to use whichever one you like better, and whichever one works better for the problem. They suggest using substitution because it's going to be easy to solve the top equation for y. All I'd have to do is subtract 3x from both sides, and I would know that y is equal to 1 minus 3x. So that was pretty quick. Now I will take that, 1 minus 3x, and in the second equation, when I have a y, I will replace it with parentheses 1 minus 3x. And then I finish writing the rest of it, plus 6x equals negative 18. And then I simplify. So I have to do the distributive property, which would be 2 minus 6x plus 6x equals negative 18. And then we simplify by combining our like terms. What is negative 6x plus 6x? It's 0. It's not 1x or 0x. It's just 0. So we're left with just 2 equals negative 18. But that is not true. 2 is not equal to negative 18. So we say, when you get something like that, when you're solving an equation, you say that there is no solution, is what you're going to write down for your answer. It's inconsistent. It's a contradiction. They're parallel lines is what's happening. And they will never have a solution. They will never intersect. So you're going to solve these 4 problems on your worksheet, and there will either be no solutions, infinitely many solutions, or if you can go ahead and solve the problem, then there'll be 1 solution. So the first thing that you'll do is decide whether you want to use substitution or elimination for each one. If it's already set up for one of those methods, then go ahead and follow that through. In number 12, I would use elimination because I could multiply the top one by 3, and then 3 times 5x is 15x. Oh, I'd multiply by negative 3. Because negative 3 times 5x is negative 15x. And then I'd have negative 3 times negative y, which would be plus 3y. And then negative 3 times negative 3 would be 9. So when I go ahead and add the bottom one to that, I will be able to eliminate. Whoa, so I can eliminate the x term, negative 15x plus 15x is 0. The y term is also eliminated, and 9 minus 9, so I get 0 equals 0. Well, that's true all the time. So you would write infinitely, I can't spell it, many solutions. If you get a true statement like 0 equals 0, then it's infinitely many solutions. So the second one, note that the equal signs are in different places. So don't think that you can just add them the way they are. You can either use substitution or elimination, whichever you prefer, but our first step should probably be getting them in the same order. So the top one is x minus 2y equals negative 8. I'm going to just subtract 8 from both sides so that they are lined up so that they're the same. X and y are in the same places. And then you can use elimination or substitution. Let's see, should we use substitution in this one? If I solve the top equation for x, I'd add 2y to both sides to get negative 8 plus 2y. And then when I plug that in to the second equation, instead of x, I'm going to write negative 8 plus 2y. And then I write the rest of the equation, minus 8y equals negative 56. And then I distribute, so I'd get negative 32 plus 8y minus 8y equals negative 56. Plus 8y minus 8y, when I combine my like terms, is 0. Not y, but just 0. So I have negative 32 equals negative 56. Is that a true statement? It is not a true statement. So you would write no solution. So if you end up with a false statement when you're done, the answer is no solution. So try 14 and 15, see what you get. And when you get to number 15, if you don't like the fractions and to try to simplify your equation, I would suggest multiplying everything in the top equation by 3, and that will then become this equation, which maybe doesn't help me use substitution or elimination yet, but it does result in a simpler equation to work with. And then from there, you still need to figure out, do I have to multiply by something so that I can eliminate, or should I solve one of the equations for a variable so I can use substitution, and then see what kind of answer you get. If it's infinitely many solutions, no solution, or if you can find an answer, tell what it is. You can use either substitution or elimination, algebraic methods, in order to solve word problems, especially problems with mixtures. So in this example, a veterinarian needs 60 pounds of dog food that is 15% protein. He will combine a beef mix that's 18% and a bacon mix that's only 9%. So he's taking 2 bags of dog food and he's mixing them together, some of each, in order to get a 15% mixture, and he wants 60 pounds of that. We don't know how much of each of the other ones he's going to use. That's what we're going to find out. We'll say X is the beef mix, and we'll say that the bacon mix is the Y. Remember that when you work with percents, we want to change them to decimal form. So this would be 0.18, this would be 0.09, and this would be 0.15. So we have 2 equations here. We have a percent equation, and we have how much food is there equation. How much pounds of each should we use? So here's your 2 equations that you're going to write. One of them is just that you're going to mix the beef plus the bacon mix, and you're going to get 60 pounds. So one of them is just by, how much total quantity you have. The other equation is the percentages. So we had to change our 18% to 0.18, and we're multiplying that by x. Multiply your 9% is 0.09 times the y, and that will equal 15%, 0.15, times 60. So we have 2 equations that look like this. So now it looks like the problems that we've been working with before. Now you may want to multiply the bottom equation by 100 so that you don't have these decimals. So that would be 18x plus 9y equals 900, and then we still have the x plus y equals 60. It would just make your numbers easier to work with if you think that's a good idea. I would probably use substitution. They're keeping with the decimals, but I would still use substitution, and I can use the y equals. So y equals 60 minus x. Let's plug my y equals 60 minus x into my other equation. So 18x plus 9 times 60 minus x. And make sure that I get the same thing if I went ahead and multiplied everything by 100 so that I would not have all those decimal numbers to work with. So now I have 18x plus 9 times 60 would be 540 minus 9x equals 900. And then I combine my like terms. 18x minus 9x is 9x plus 540. And then I have to subtract 540 from both sides. So I would have 9x equals 360 divided by 9, and it tells me that I need 40 pounds of the 18%, the beef dog food. Which means then that if that's 40 pounds and I needed 60 altogether, that I need 20 pounds of the bacon mix. And that's the last step, is just to go ahead and once you find both variables, then you would write what your answer means in terms of, you wouldn't write an ordered pair for this because x is the beef mixture and y is the bacon mixture. All right, that's it. Thank you very much. Good luck. Let me know if you have any questions, and have a wonderful day.